Hey guys, today I'm going to talk about how you can create a K3D cluster locally in your laptop. But today, what I am demonstrating is not laptop. I'm going to use a machine in AWS, an Ubuntu server. But this same thing, what I do on a Linux machine, can be done on a Windows PC, or it can also be done on a MacBook. And I will explain what are the software that you need in your own laptop. So today I'm going to use an Ubuntu server and create a K3D cluster. So first of all, let me log into the machine. This is the AWS. This is a machine in my AWS account that I have created, and I am currently logged in. And now I am going to install all the necessary software to run the K3D cluster, and I am going to explain you what are the different software that you need to run the K3D. So a few things. The first of all, you need Docker installed. So if you are using Ubuntu, you can go ahead and follow the Docker documentation for Ubuntu. Or if you are using MacBook or Windows, you can go ahead with the software Docker for desktop, Docker desktop, and Docker desktop would do the job for you if you are using Windows or Mac. Or otherwise, you can go with the apt-get installation of the Docker CE package. And then you should have Docker installed. And second thing, you should have kubectl installed, because after you created the cluster, to manage the cluster you need kubectl. So that is why kubectl should be installed on your machine. And again, whether you want to install kubectl on MacBook or Ubuntu or Windows, the process is pretty much very simple and straightforward. You can search in Google and get the documentation for kubectl and get it installed. And then the last thing that you have to install, you should install K3D. K3D is the tool that would help you create K3s clusters inside the Docker containers, and that is why you need Docker. K3D runs Kubernetes cluster inside the Docker containers. So yeah, containers inside container, that is how the K3D works, and it's absolutely fine. I mean, you don't miss any important features of Kubernetes just because you are using containers. K3D is a software that was actually developed by removing those not so important features of Kubernetes, right? And that is how K3s has come into picture. And K3D makes the cluster creation pretty simple and straightforward. So let's not get into too much technical details of these things. So these are the software that you need to install, and once you install these softwares, your laptop is ready, or whatever machine you are installing the software, the machine is ready to run a K3D cluster using one single command that takes less than 60 seconds to complete, to create a Kubernetes cluster locally. So let's get started. First, I'm going to install Docker. So in my machine, I can use apt-get. If you are using Ubuntu, you can use apt-get update and apt-get install to install Docker CE package. And better, I will check the Docker documentation and the Docker website for the documentation. So install Docker. Install Docker on Ubuntu. You can search in Google something like this, and you will be taken to the official Docker documentation. And they have a different documentation for MacBook and different documentation for Windows and for Ubuntu. So I am going with the option Ubuntu, and I'm going to install Ubuntu using some repository, the apt-get. So I'm going to blindly follow these steps. You are right. And first I will run the apt-get update command, and then I'm going to execute this apt-get install command, copy it from the Docker documentation. This is not Docker that I am installing. This is some initial software that must be installed before installing Docker, and then I need to add some Docker official GPG key so that apt-get can recognize the package that it is downloading. And then I am adding the apt-get repository for Docker, and then I will go ahead and install Docker using the apt-get update and apt-get install command. So this is how you will install Docker on Ubuntu operating system. Basically, literally what I did is I just went to the Docker documentation and followed the commands one by one. until here, starting from apt-get update, then apt-get install here, and then adding the signature, adding the repository, apt-get update, and apt-get install. These are the packages that you need to install to run Docker successfully inside a Ubuntu server. And if you are using MacBook, you can always search in Google Docker desktop for Mac. For Mac or for Windows, just search in Google for Docker desktop. Then you would be again taken to the official documentation of Docker website, where you can download and install Docker desktop for MacBook or Windows PC. So you can just go ahead and click this button and get it installed on your MacBook, or you can install Docker desktop on Windows as well. Just search for Docker desktop for Windows, and you will be taken to the respective URL where you can download and install Docker desktop on Windows. So this is how you install Docker. And Docker can be installed on Ubuntu, it can be installed on a Windows PC or a MacBook. And now you have installed Docker, and the next thing, we can go ahead and install kubectl. Kubectl is the software that you should have inside your laptop if you want to remotely manage a Kubernetes cluster. So go ahead and install kubectl. You can search in Google how to install kubectl on Ubuntu. Then you would be directly taken to the official Kubernetes website, where you can find the instructions to install kubectl on Linux, on MacBook, or on Windows. So today I'm going to use a Linux operating system. So yeah, I'm going to go with these steps. They had given me some script to install kubectl. I'm just using that, right? It's just a matter of a single command that I need to run, and then two commands. So let me go to the command line, and this command I can use for downloading some script which will do the automated installation of kubectl on my Ubuntu server. And then the next command I can run, that is for validating the binary. That is optional. If you want to do it, you can do. And then the next command will copy the kubectl binary to the respective system binary on my laptop. And today, like I said, I am working on a Linux machine, and kubectl is now successfully installed. You can run the command kubectl ---- version to confirm, or kubectl version. Yeah, you can run the command kubectl version to confirm the kubectl is successfully installed onto your Ubuntu server. So we are done with two steps. First step, we installed Docker. Next step, we install kubectl, and now we are going to install K3D. So let me go ahead and install K3D, and for that I can go to the website, search in Google K3D install, and I go to the K3D official website, and you can just simply scroll down and you can see the installation script. This is a scripted installation, so a single command you can copy, whether you are using MacBook, Windows, or Linux. This command is going to I think for Windows the steps can be different. This is only for Linux. Okay, Linux or Mac, you can use this for Mac. And on Windows, if you are using a Gcloud for installation, this package you can install on your Windows. And in my case, I am going with the scripted installation. I can use wget command, or I can use curl command. Any one of the command is absolutely fine. The single command will take care of all the installation. So I will go to my machine. In my case, I am using an Ubuntu server from AWS, and I am running that script inside that server, and this script will take care of the K3D installation, and it's done. K3D is now successfully installed on my machine, and you can run the command K3D --help. Then you can see what are the different options available within K3D, and my intention is I want to create a K3D cluster inside this machine. So the command is k3d cluster create. K3d cluster create, this one single command will create a local K3s cluster inside your machine, right, using Docker containers. And you already know, in order to create a Kubernetes cluster, you need a whole bunch of machines, right? I mean, that's what I have already told you. You really need a lot of machine to run Kubernetes properly. You need a number of machine where you want to run different management components of Kubernetes, and then you need a number of machine where you want to run different containers that your company manages. So at least there should be 6 machines to run different applications. And a proper Kubernetes cluster generally consists of a number of machine. But in our case right now, what I did in my case, this is an AWS machine I am using, and instead of an AWS machine, it could be your MacBook, or it could be a Windows PC that you are using. It doesn't really matter. The only requirement is that Docker should be installed, K3d should be installed, and then kubectl should be installed as well. And if you have these 3 software installed in your machine, then you can actually create a Kubernetes cluster. And this Kubernetes cluster, whatever I am going to create, we will not be using machines to run different Kubernetes component. Instead, we would be using Docker containers, and that is why you install Docker, right? So Kubernetes want some server to be there, and there should be some control plane component of Kubernetes, and there should be some worker component of Kubernetes. And K3d makes things pretty straightforward. It would be using a number of Docker containers, and different software that Kubernetes need to run, they will run inside these containers. So literally you will get a Kubernetes cluster at the end, and you don't really care whether this cluster components are running inside a container or inside a real machine. That is not important. What you got at the end is a Kubernetes cluster, and now you can start deploying your applications as containers inside this local cluster. So the advantages of K3d is that it is a very lightweight, and this is not really the actual Kubernetes cluster that K3d uses. K3d uses K3s, which is actually a lightweight version of Kubernetes, and it is not an official Kubernetes release. K3s is a software managed by Ranger, that is a different company, and who took the Kubernetes code and removed all those unnecessary components and all those components that you might not use, and they removed most of the complexities of Kubernetes and put that inside a small 50 MB lightweight binary. And that binary consists of all the Kubernetes component, the API server, scheduler, and whatever components that you really need. So what you have just created is not a Kubernetes cluster, it is called a K3s cluster, which is a lightweight version of Kubernetes. But actually, in most of the cases, this is good enough, right? K3s works in most of your use cases. It supports deployment, it supports services, it supports different methodologies for setting up ingress, secret management, config maps. Most of the resources that you create in Kubernetes cluster, you can create them here. And yes, it is missing some feature, but most probably those features are not something that you use on a day-to-day basis. So on a laptop environment or on local environment, you get a Kubernetes cluster with most of the benefits that you really need, and maybe some features may be missing, but most of the features that you normally use are still there. So this is the idea. So I'm going to create this cluster inside my laptop or whichever machine you have K3d installed. So go ahead and run the command. The command is K3d cluster create, and this command will create a local. Okay, let me re-log in. I got disconnected from the AWS machine where I have been working. I'm just reconnecting, and I'm going to execute the command K3d cluster create, this single command you just run, and that's it. And that's it. Seems like it is trying to download some Docker images, and it is trying to create some Docker containers. It is creating some K3s containers. K3s is not actual Kubernetes. I already told you it is a lightweight Kubernetes which contain only the most important components of Kubernetes that you might use. And it is currently a Docker image, and looks like the k3d command I executed is downloading that Docker image and creating some container, and these containers that are going to get created are actually the going to act as the container host in my Kubernetes cluster, right? You got the point. So a Kubernetes cluster need worker nodes and control plane, and yes, K3s cluster also need that, and in our case it is there, but they are not real machine, they are Docker containers, and that is why we install Docker in the first place. All right. So and yeah, you don't care whether in the underneath whether it is Docker or real machines, it's not important. At the end what you have got is a Kubernetes cluster, and you can work on that Kubernetes cluster using your kubectl command. Kubectl config get context is the command you can see to check the cluster, the name of the context. This is the context Kubernetes cluster that you are currently working on, and you can run the command kubectl get nodes, and you can see there's a node running on. It's a single node cluster that we have created, but you have the flexibility to create multiple node if you need. We will try that a little bit later, and right now it is a single node cluster that is running, and I am able to run the kubectl command successfully, and I can run the command kubectl get ports. I can see all the ports. Right now there are no ports running inside the cluster, that's why it's empty, but if I want, yes, I can create them. So, and if I have a pod manifest, let me create some symbol pod inside this cluster. What I will do is I'll just go ahead and get pod YAML file from the internet, from the Kubernetes website. I'm going to copy a sample pod.yaml file, and then I'm going to, this is an nginx pod, I'm going to create this nginx pod inside the K3s cluster. So over here I'm going to create a file called nginx underscore pod.yaml, and I just pasted the content over here, and I'm going to execute the command kubectl apply -f, then the YAML file, and you can see the pod got created. Seems like the pod got created. You can run the command kubectl get pods, and you can see the pod being created inside your local cluster. And remember, this local cluster is running in your laptop. So basically, without any external help, without using any cloud provider, you got a cluster up and running inside your laptop, and you can do most of the things that you do in Kubernetes cluster in here. So now your nginx pod is running. So now it's time you can run some applications like CoIT frontend, CoIT backend, CoIT backend 2, or WordPress, MySQL, whatever application that you want to try. You can start running those applications inside a K3d cluster, and it has lots of benefits, right? So in the last session you have seen how to create a single node cluster, and in this session I'm going to specify how to create a multi-node cluster. You can run the command k3d cluster list to see the list of cluster that you have created so far using K3d. So I already have a cluster running, and the name of the cluster, I did not specify any name, but by it auto generated some name. But if I want, I can specify a name for the cluster that I want to create for sure. So what I'm going to do is I'm going to execute this command. I'm going to create a new cluster, but this time it's going to be a multi-node cluster. Right now, I can run the command kubectl get nodes. There's only one node in the current cluster that I am working on, and if you want to check which cluster you are currently working on right now, anyway there's only one cluster, but using kubectl This is the command you can run to see the context that you are currently working on. Right now there's only one cluster, that is where you are working on, and we already created a port and Nginx port. Sorry, we already created a Nginx port inside this cluster. All looking good. So now I'm going to create a new cluster. Right? Now I'm going to create a new cluster, and this new cluster that I am going to create, I already have a cluster that I created, and inside the cluster by default there's only one node cluster. It's a single node cluster that I have created, and now I want to create a cluster that would contain 4 nodes, 2 master nodes and 2 worker node. That's my plan. So this new cluster that I am going to create, it is going to contain 4 nodes, and then yes, of course, whatever containers that you create inside, these are the actual machines which run these containers. But yeah, remember, these are not real machines. These are Docker containers. That's what K3D is all about. K3D uses Docker containers to run the Kubernetes cluster. Yes, containers inside containers. The Nginx container that you created is actually inside this Docker container. Technically that's what it is, but you don't care. You don't really care, because K3C simplify, K3D simplify all these things. You can completely forget about the machines, whether they are containers or real. You can focus on kubectl and working on the cluster using YAML. And right now the cluster that you created is a single node cluster, but in production you might have multi-node clusters, and you might want to do a whole bunch of testing on multi-node clusters. So a developer wishes to create a cluster that contains more than 1 nodes. So let's see what you can do using K3D. Now I'm going to create a second cluster. I already created this cluster. Now I am going to create a second cluster using this command kubectl. Kubectl create, cluster create, and then I can mention the name of the cluster that I am creating. So I mentioned K3D multi-node, that's the name I am giving. Then I can mention surveys equal to 2, or whatever number that you want to give, agents equal to 2. So I'm going to create a cluster, and this time I'm giving some name. Last time I did not give any name, it auto generated some name, and this time I am manually passing some name. And then I mention I want total 4 nodes in the cluster, 2 control plane nodes and 2 worker nodes. Surveys is nothing but the control plane nodes, agents is nothing but the worker node, and when it comes to K3D, that is what it call it, just surveys and agents. So just go ahead and run this command. Sorry, it's not kubectl, it's K3D. And as soon as the K3D cluster get created, it would generate all the necessary certificate for kubectl, and kubectl will automatically start talking to this cluster. Even last time also we did not did any kubectl specific configuration. As soon as the cluster is created, kubectl start working on that cluster. So same case will happen here also. So let me run this command and let me create a second cluster, this time with 4 nodes in it. So you can see it's basically creating the nodes, and it's creating the cluster. It's creating 2 server nodes right now, starting the 2 server nodes, and then a bunch of nodes, server node and cluster nodes got created already. Now they are being started. It won't take much time. It hardly takes less than 1 minute to create a cluster, and that is the best thing about K3D. It's lightweight and it's very fast right now. So it's done. The cluster is ready, and now we can run this command. There is a command called K3D clusters list. Then it would show you all the clusters that you currently cluster list. Sorry, it's not clusters, it's K3D cluster list. Then it would show me all the clusters that you currently have. So there are 2 surveys and 2 agents, and all of them seems to be in the running state. Everything looks good and perfect. And then I can now run the command kubectl So now I have two clusters. So which cluster right now kubectl will be speaking with? Is it the default cluster, single node cluster, or the multi-node cluster? You will have this doubt always when you work on your laptop. So just run this command to confirm at a given time which cluster kubectl is speaking to. Run this command config get context on kubectl. Then you can see all the clusters as context in the list, and there is multi-node context and there is default context. This is the old cluster and this is the new multi-node cluster, and star button indicate which cluster kubectl is speaking to right now. So right now kubectl is speaking to this cluster, and I can run the command kubectl get nodes. So I already know there are 4 machines or 4 nodes forming this cluster, and I should see 4 in the output. Yes, there is 4, and 2 of them are taking care of the control plane roles, and 2 of them are nothing but the worker nodes. So total 4 nodes in this cluster. And any containers are running inside the cluster, we can run the command get ports. It will show you all the ports that are currently running in the given cluster, and right now obviously we have not created anything, so that's why it is showing us empty. So let me go ahead and create a cluster, create a pod inside this cluster by running kubectl apply command. I already have an nginx pod YAML file configuration. So now I am creating a new pod inside the new cluster. So you can now go to, so an nginx pod got created in the new cluster, and the old cluster also I already have created this pod. So now you have seen how we can create multiple clusters in your laptop itself. Yes, currently I am using an AWS machine, but I strongly recommend you that you use your laptop, MacBook or Windows, whatever operating system that you use to run these softwares. You can run a K3D cluster locally very easily. So you can, just use your laptop, and many developer today uses this methodology. They develop some application and they want a local Kubernetes cluster where they want to run the application which they are developing for the testing purpose, right? So always it's best if developer has a local Kubernetes cluster within their laptop, and Kubernetes K3D is widely used for this purpose to run some workload in the developer laptop itself. And K3D is actually a very good project, lightweight, and it does not take a lot of memory and CPU. So it is best for laptops, it is best for IoT devices also. I mean, the lightweight IoT devices can also run K3D clusters. It's that much lightweight, right? So that's what it is, and most of your lab environment K3D will work, right? Whether you want a single node cluster or multi-node cluster, you can create using K3D. And most of the Kubernetes resources that you create in Kubernetes, you can create them in a K3s cluster also. So most of your lab environment will work with K3D. Okay, great. Okay, now you have 2 cluster in your laptop, and now you want to clean up the cluster. So your developer, assume you or your developer, you can now start deploying your applications into this cluster, the CoIT frontend, CoIT backend, or CoIT whatever application that you want to deploy, shopping cart application. Your company have different applications and you want to run them as containers. You can start running them across different clusters that you have currently created inside your laptop using K3D. And now, after a whole bunch of testing, you decided to delete everything. You want to delete the cluster completely, and that is also very quick and very fast process. You can go to the command line and check this command K3D cluster list. You can see the list of cluster that you currently have, and if you want to delete one of those cluster, the command is K3D cluster delete. Then what happens is everything get deleted, the cluster get deleted, all the ports, all the workload that you run inside the cluster get deleted, and all the nodes that form this cluster get deleted. I mean, those Docker containers that was created when you created the cluster, they all get deleted, and your laptop would become absolutely clean. So this is also a nice cool feature, and it takes only few seconds, 5 seconds, less than 5 seconds to delete a cluster, and now the cluster is completely deleted, and now you are left with only one cluster. Now I'm going to delete this cluster also. You can use the command k3d cluster delete followed by the name of the cluster, and now this cluster is also deleted. So now your laptop is clean, or not, right? You can create or delete the cluster as you wish with a single command, and you can start deploying your application or deploying your containers into that Kubernetes cluster locally very fast, right? So that's the advantage, and most of our lab environment K3D works. So I need a Kubernetes cluster. And I'm going to create this cluster in the Google Cloud. I need a Kubernetes cluster, and most of our lab, what we do, we will be doing it on the Google Cloud cluster, and we are going to create this cluster. So from my laptop, what I'll do is I'll use my laptop, not the AWS machine. I'm going to use my laptop throughout this training to do the experiments. So in my laptop, I would install Helm. I would install customize is, and install customize. I will install Argo CD. Is not something that you install here. Argo something has to be installed in the cluster, but there is an Argo command line, Argo CD command line, that I will install in my laptop. So I would be using my laptop to install all the client software that I want to install, and then I would be installing server software inside the cluster. So I definitely need a cluster, and I already created I'm going to create a Kubernetes cluster, and then I should be able to connect to this cluster using kubectl. So these are the things what we are going to do next. Let's set up the lab environment for the GitOps training. So this is my Google Cloud account. You can also register yourself for a Google Cloud account, and they provide you $300 credit. You can use that credit to create your cluster, so you won't lose money from your pocket, right? And you need a credit card. So if you don't have a credit card, try to get some help, right? You need a credit card, debit card. Some debit card works actually, but most debit cards don't work. You can try with your debit card, but most debit card don't work in the Google Cloud. You might need a credit card to create your account. You can use a Google account. You can just go to this URL, console.cloud.google.com. Then you can log in with your existing Gmail ID and password, and then you have to enable the next. It will ask you to enable the billing account. So you have to enable the billing account. Then it will ask you to create a project. You have to create a project, and you have to do these many things first before you can start creating a Kubernetes cluster. So go ahead and do that. Create yourself an account in Google Cloud, and then let us create a cluster. So go to the menu, and every time you create a Google Cloud account, when you activate it, it will ask you to create a project. In my case, the name of the project is my first project. It can be anything. You can change this name, or if you want to create a new project, you can create a new project. So every time you create a Google Cloud account, they will ask you to create a project, and whatever resource that you create would be coming under this project. So this is just for your cloud resources orchestration, and it's mandatory. You should create a project, and whatever things you create, it could be Kubernetes cluster, or it could be a machine. Anything that you create inside Kubernetes cluster has to put under a project. So just some concept, that's all. So I'm going to create a Kubernetes cluster, and once you activated your billing account, for that they will ask you to verify your card information. Every time you log in, when you log in for the first time, they will ask you to enable the billing account. So provide your card information and get your card verified, and once it is verified, you would be able to create a Kubernetes cluster. So for that, click this button, and go to the Kubernetes engine, go to this service, and I'm going to create a Kubernetes cluster here. So in the cluster tab, click on the create button over here on the top, and you can select this option GKE standard. Give it some name. Okay, I can give any name. Let's say DevOps or any name, DevOps or GitOps. I'm going to call the cluster with the name GitOps cluster. And then zonal, yeah, keep it zonal, not regional, keep it zonal to save the cost. And then Kubernetes version, don't change anything. Click on default pool, number of nodes, how many worker node do you need? That's what they are asking. I need 2, mention 2. That means, the Kubernetes cluster will consist of 2 worker nodes. That's what it means. 2 machines, 2 Docker host or whatever you want to call it. 2 Docker host or 2 container host will be there, and they will be the actual machines who run the containers. When you run a container in the cluster, these are the actual machines inside which the containers are running, right? We already talked about Kubernetes architecture, you know that. So I'm not explaining it again. All right, so we come here and we are mentioning I need 2 worker nodes, and that's all. Then the machine size, if you click on the nodes, you can see the size of the machines. Let it be 2 CPUs and 4 GB memory, let it be. That's it. You just go ahead and click the button create, and the cluster will start to get created. It is as simple as that. Creating a cluster in the Google Cloud is just basically a 1 minute process, and it takes another 2-3 minutes for the cluster to become ready. So we have to wait until the cluster become ready, and once it become ready, we can start connecting to this cluster. That's the stuff. So you already created a Google Cloud Kubernetes cluster, and it is sitting somewhere in the Google Cloud. It is in Mumbai, or it is in some location in India or in some other country. I created the cluster, and I am with my laptop, and in my laptop I am going to install kubectl, and kubectl want to speak to the Google Cloud. And if kubectl want to speak to the Google Cloud, I want to download the necessary credentials of the Google Cloud, and I want to store them in my laptop at this location, .kube config folder. I want to download the certificates, some credentials from the remote Google Cloud cluster. And to do that, I can use Gcloud command line utility. That is a command line provided by the Google Cloud. Every cloud provider gives you a command line. You can work with the cloud provider using command line rather than using a browser, right? Gcloud command you can use to create a cluster. Gcloud command you can use to create a machine. Gcloud command you can create a disk. Whatever you want to do inside your Google Cloud, you can actually use Gcloud command. But today we are not going to learn Gcloud command. I'm just setting up Gcloud command so that I can get those kube config file downloaded. That's all. So in my laptop, I want to generate a file .kube/config. I want to create this file in my laptop. In order to do that, I should be authenticating to my Google Cloud account. Then I want to download this certificate from the cluster and put that in this file. To do that, I need the Gcloud command line. So only after that you can use kubectl command. So let me install Gcloud on my laptop. And it is again pretty straightforward. You can either use apt-get or you can simply follow that Google provided. Install Gcloud. So you can just simply search in Google, install Gcloud, and then it will take you to the Google documentation. It just whether you are using Windows, Linux, or MacBook, it is not important what laptop do you use. There are instructions. If you are using MacBook, this is the instruction. If you are using Windows, these are the instructions. If you are using Ubuntu, these are the instructions. If you are using an AWS machine to set up all these things, you can go to this documentation. Let me go to Mac. I am using Mac. I'm going to install things in my laptop. You can follow the Windows option. I strongly suggest that you use your laptop, right, to install stuff, and it's just a download and next install. Pretty straightforward on Windows. And on Mac, I can use this script to do the installation. I can download this file, extract them, and then Gcloud Init. So basically, all I need to do is just download this file. If you are using Mac, you just need to download it and use it. That's all. So that's what I'm going to do. I'm going to download this file in my laptop. It's getting downloaded to my laptop, and it will be in the downloads folder of my laptop. This is the file name, and the file get downloaded to my laptop in the downloads folder. So let me, in my laptop, this is my laptop, not the server. In my laptop, I go to the downloads folder, then I type the command ls. Okay, I think I already have this file downloaded. So this is the file what I already have. And in order to extract this file on Mac, you can use this command -xzvf followed by the file name. It will get extracted. And if you are using Windows, you can simply configure Gcloud. Gcloud is just a software anyone in the world can install, right? Now you have to configure Gcloud by using Gcloud init command. Basically, using the Gcloud in browser, it is pretty easy and straightforward. You go to console.google.com. It will ask you for your Gmail ID and Gmail password. You enter your Gmail ID and Gmail password. You are logged into the cloud, and then you can click the buttons and do the stuff. Same thing you can do using the Gcloud command line. That is what I'm saying. Same thing what you do in the browser, you can do it using the Gcloud command line. So how you will authenticate from the Gcloud command line? So you have to do that, and that's what I'm going to do. So in my laptop, I currently have, and I'm going to execute this command now, Gcloud init, and to log in to my Google Cloud account. I already have a Google Cloud account. My Gmail ID and Gmail password I have. I want to log in with those credentials to my Google account, and then download the certificate or whatever I want to do. First of all, I want to log in. So I'm going to run the command Gcloud init on my laptop after installing the Gcloud command line. Let me now execute Gcloud init. So run the command Gcloud init. Then it will ask you, okay, in my case, actually I am already logged in. So in your case, it will ask you to create a configuration. I'm going to do the same thing as you, right? So I go with the option create a new configuration. In your case, you have to, you will have nothing. So it will ask you to create a new configuration. So that's what I'm doing. Go with the option 2. And they are asking me to specify some name for the configuration. I say GitOps learning. Press enter. Then it will ask you, what is the account that you want to use this operation. So I want to use basil@what.tech. This is my Gmail ID. This is the Gmail ID and password that I'm using for my Google Cloud. My Google Cloud account email ID is this. So I go with option 1. Now I am logged in. So in your case, you won't be logged in. They will give you, they will open your browser. They will ask you to log in and copy a code here. So you will have to do that if you are using, if you are doing it for the first time. So in my case, I was already logged in. Otherwise, it will open your browser. Then in the browser, you have to log in and validate yourself. And you may have to copy a token. They might also ask you a token. In browser, you will get a token. You have to copy paste that token in this command line when they ask you for the token. So you have to do this. And then it is asking me what is the project that I want to work with. So I already have a bunch of project. When you created your Google Cloud account, you would have already created. In my case, it is I already created this project when I created my Google Cloud for the first time. This is the ID, Rising Area 331809. So I'm going to use that over here, Rising Area 331809, number 2. Press enter, and that's it. Do you want to configure the default region unzone? Yes, I want to do that. So currently, whatever cluster cloud, that cluster I have created in US Central 1C, that is the location. So I want same location to be set as the default location. So that's what I'm doing. I set yes, then I'm going to mention I want to set US Central 1C, which is number 7. So I type number 7, press enter, and that's it. Gcloud command line is successfully configured inside your laptop. You have logged into Google Cloud from the command line, just like how you log into the Google Cloud from the browser. This time you used a command line to log into your Google Cloud account. Awesome. And what is next? So why did we do this? Why did we configure the Gcloud command line? So that we can download the kubeconfig file. Config, right? Search in Google something like this. What is the command I should use to download the kubeconfig? That is my intention. That is the reason altogether, why I installed Gcloud. I wanted to configure Gcloud because I wanted to get download the kubeconfig file of the cluster that I just created in the Google Cloud, that GitOps cluster, whatever cluster that we just created, GitOps cluster. For this cluster, I want to download the kubeconfig. So I search in Google, I go to the Google Cloud documentation page, and I will get the command. Gcloud init command we already executed, so don't worry about it. Kubernetes configurations, we already created the cluster from the browser, so don't worry about that also. Cluster we already created, and authentication with kubectl, that's what I want to do. And for that, the command is this. This is the command to generate the credentials, the kubeconfig, Gcloud container clusters, get credentials, and over here I have to specify the name of the cluster. So name of the cluster is GitOps cluster. So this is going to be the command which I will run on my laptop. So this is the command I have to run on my laptop. Then Gcloud will connect to my Google Cloud account, generate, locate this cluster in my Google Cloud account, then generate all the necessary credentials, and that would get downloaded, stored in my laptop. So let me execute this command in my laptop. So just run the command in my laptop, and that's it. It says kubeconfig entry generated for the GitOps cluster, and that file in my laptop is this .kube folder, config file. Whatever your home folder is in your laptop, right? Inside your laptop home folder, .kube config. This is the file which got updated with the new cluster credentials. And actually, if I show me my file, it is complicated because same file contain too many clusters, AWS cluster, K3D cluster, many clusters. So it's a bit complicated. And a entry got generated for your Google Cloud clusters. Just search for GitOps. Some entry might have come here for GitOps cluster. Take a look. So this is the one, a new entry has generated for the GitOps cluster, and along with some certificates, some credentials. And this is the URL that kubectl will use to talk to the Kubernetes API server. All right, fine. So I can use this command also, kubectl config get context. I will be able to see the new cluster that I have created. And yes, star button indicate that currently I am connected to that cluster. So everything good, everything good. I am all set. And yes, if you don't have kubectl installed in your laptop, you should install kubectl also. Kubectl, just download and install, or you can use apt-get, or kubectl installation is pretty straightforward. So now I am going to run my first kubectl command, kubectl get ports. How many pods are currently running inside the Google Cloud cluster that I just created? Nothing. Get nodes. How many worker nodes are there in the cluster? Two worker nodes are there in the cluster, right? At the time of creating the cluster, I just mentioned I want two worker nodes. You can see them. So just, now you successfully created your lab environment in the Google Cloud, and then connected to the lab environment to that cluster using kubectl from your laptop. So that's what this is. Okay, let's talk about what are the various clustering options. So basically there is K3D. K3D is a local software developed by Ranger. So first of all, there is Kubernetes. Kubernetes, as I said, it's an open source software. And if you search yourself in GitHub, you can get the open source code, the code of Kubernetes, right? You can go to GitHub and search for Kubernetes. You can find the official Kubernetes GitHub repository. Just search for Kubernetes. And then over here, you can see this is the official Kubernetes. There are more than 1 lakh clicks, commits, changes that were made to the code of Kubernetes. And there are 32,000 people who took a copy of this code, and probably they are trying to make some changes to the Kubernetes code all by themselves. Maybe they have a custom requirement to do that. So this is the original code, and you can download the code by clicking this file. Yes, it is a complicated software. Most probably, if you are not an expert developer, you might not understand most of the parts. But what I'm trying to say is, if you have a big team and you decided that you want to develop your own Kubernetes cluster, you want to add a lot of features to Kubernetes, you want to remove features from Kubernetes, it's very easy. And you don't, but if you are somebody who want to create a cluster, you don't have to learn the Kubernetes source code. It's not important. You can just download the source code as it is, or you can download Kubernetes as it is, and then you can create your own Kubernetes cluster on your premises without worrying too much about the Kubernetes code, right? You don't have to. For installing Kubernetes, there are easier methods available. There are executable files that you can download. You don't need the source code for that. You can just search for how to install Kubernetes on premise, right? Install Kubernetes on premise, search in Google. There are tools such as kubadmin, various tools available that can automatically install Kubernetes into various machines that you have locally. So that is possible. You can install a Kubernetes cluster or run a Kubernetes cluster all by yourself. It's a free software. Just find the right documentation. There are even automated tools that would allow you to do the installations in a automated way. It's you can complete the installation in less than 15 minutes, and you can create a cluster all by yourself using a bunch of machine that you currently have, and a minimum 3 machines are recommended. So that is one option. The companies can use Kubernetes and create a cluster all by themselves. And then there are managed clusters, managed Kubernetes clusters in the cloud. So all cloud computing providers, whether it is Google Cloud, whether it is AWS Cloud, since Kubernetes is open source, anyone can and they are capable people who can download the source code of Kubernetes and make the customization the way they want it, right? They can directly go to GitHub, they can download this complete code. It's a huge code base, complicated code, right? Which consists of more than 1 lakh changes made so far. So but the cloud computing provider, what they had done is they they got Kubernetes and they customized Kubernetes the way they want. and they configured Kubernetes to work with their internal use and most of the other services that cloud computing provider provide, such as load balancers, disk, virtual machines, network services. There are various other services that every cloud computing provider provides. So they used they used Kubernetes to customize Kubernetes in such a way that it can work with those internal services that the cloud provider already provides. So every cloud provider do this. They take Kubernetes code, they make some customization, and they don't make a lot of changes in the Kubernetes core. Kubernetes has various components, various small software components. So cloud providers can just work only on a specific component. It's called Cloud Controller Manager, which they can customize and configure Kubernetes to work with their systems. So anyway, we don't have to bother too much about how the cloud provider did that, right? It's not your concern. But most of the cloud provider today, they allow you to create a managed Kubernetes cluster in the cloud. You can log into your cloud provider, click few buttons, click, and within few minutes you will get a cluster ready. And then every cloud provider also tells you once the cluster is ready, using kubectl you can speak to that cluster. So a DevOps engineer who has kubectl installed, just like he speak to a K3D cluster, he can speak to a Google Cloud cluster, he can speak to an AWS cluster, he can speak to the cluster whichever cloud provider that he is using. So, and that is an option in Google Cloud. It's called GKE, Google Kubernetes Engine. AWS, it's called Elastic Kubernetes Service, EKS. So you can either create an EKS cluster in AWS, GKE cluster in Google Cloud, or AKS cluster in Azure, right? Most cloud computing provider today, they support Kubernetes because Kubernetes is so much popular and Kubernetes is today everyone's day-to-day need, right? Most of the company need Kubernetes, so every cloud provider must provide this service, right? Because people want to use Kubernetes, and cloud providers make it much easier by providing a lot of extra services. So what are those extra services? So that would include the load balancers, for example, some load balancers, for example. So assume you have a Kubernetes cluster and you are running your containers inside that cluster. And now you want to receive traffic from the internet, right? You want to receive traffic from the internet. So you have, think about your CoIT front-end application, and it want to receive the traffic from the internet. So AWS, Google Cloud or AWS, whatever your cloud provider is, every cloud provider has a load balancer service, and that is where your customer should be sending the traffic. The people all over the world, when an incoming connection need to come to a Kubernetes cluster, technically, if it is coming from outside world, then there should be a load balancer that is sitting in the front. And what this load balancer does is it will accept the connection coming from your customers. Maybe they are browsing, maybe they are doing something else. They will always speak to, whenever they want to speak to the application, they will speak to a load balancer. And the load balancer has to redirect the traffic to one of the backend containers that you have inside your Kubernetes cluster. This is how in real time you accept traffic from the customers. There should be a load balancer to which all your customers should be connecting, and then the load balancer will send your customers to one of the pod in the backend. That is how the application receive traffic from customers using a load balancer. So apart from creating a Kubernetes cluster, you may want to create various load balancers. Maybe the front-end application want to receive traffic from the load balancer. The Java application want to receive traffic from the internet. So there may be multiple load balancers that you might need. So, and you want to create the load balancers based on the requirement. So apart from creating the Kubernetes cluster, now you have one more responsibility. You want to manage the load balancers. So you don't have to, fortunately. If you are using the cloud provider has a load balancer and it is already integrated with your Kubernetes service. So as a DevOps engineer, you can specify, I need load balancer as the service. And that's it. Rest of the things your Kubernetes cluster takes care. Your Kubernetes cluster in the cloud will talk to the cloud provider load balancer service, provision a load balancer, make it ready to accept the traffic from the internet, make it ready to send the traffic to your application correctly. So all these things will happen automatically. All you have to do is, all your DevOps engineer has to do is, when they create a service for this application, they will mention that service type equal to load balancer. This is just an example that I am saying. This is not the only advantage. So later on, you want to do something else. You have a lot of containers and they want to store some important data. So the data should be stored in a permanent place, right? When you have some not stateful applications, they want to store important data. That data should be stored inside a secure place. Even if the container get deleted and a new container get created, right? Kubernetes do that a lot. It create delete container, create containers. Kubernetes do that a lot. So when a container get deleted, what will happen to the data? Right, that is important, right? So the data should not be stored inside the container. Instead, the data should be stored inside a dedicated disk, right? It should be stored inside a disk, and that should be probably, it can be outside the cluster, it can be somewhere else that you have set up, it could be a disk. And if you are using cloud, every cloud provider provide such kind of disk services. It is like a pen drive sitting in the cloud. So when you configure your application to store some data, rather than storing data internally inside the container, you can choose to create a disk in the cloud and store the data. Your container can mount to that disk, and then all the data you can store in that disk. So even if the container get deleted and the new container got created, the data will stay same because data is not inside the container. So you want to do this for your important data. Maybe not all data are important, but think about some stateful application you have. It is storing some data inside the container. Then that is important data. If the container is deleted, the data is gone. You don't want that. So whenever your application want to store some data, it should be stored inside and I said permanent disk. So if you are using cloud, you don't have to worry about creating the disk and managing the disk again. You will write it down inside your manifest again. You would mention, I want to create a disk to store my SQL application data, right? And then you just mention that inside your YAML file. And then rest of the things, your GKE cluster or your cloud Kubernetes cluster takes care. It provision a disk in the cloud and then mount that disk to the container. So all those instructions you can write inside the file. So that is your job. As a DevOps engineer, you just manage the Kubernetes cluster, and then your cloud provider already did a smooth integration. These are outside services from the cloud provider. These are not internal Kubernetes services. Load balancing, disk, then networking, machine creation. You need lot of machine to run the cluster. So machine creation, everything is outside services of Google Cloud, right? So, but even though they are outside services, you can manage them just like Kubernetes can manage them all at one shot. And as a DevOps engineer, you just write code for everything. When you want a disk, when you want the disk to be mounted to your application, when you want a load balancer, you want the load balancer to be connected to your application. When you want a network, when you want a machine, you write YAML file, you write the decide state and run the kubectl apply command. Then your cluster will do the rest of the action. So this is important for many companies today, and that is why Kubernetes is best run in the cloud unless your company has a specific requirement. Like assume you are a bank, you have strict compliances that you want to meet. The cloud provider don't meet those compliances, then you have to run it in yourself in your own machines, right? Otherwise you don't have much strict compliances and things like that. Then running Kubernetes in the cloud is probably the best and easiest option for everyone, because the cloud providers, when they
create the managed Kubernetes service, they will make sure that all other services that you need are properly integrated with the system so that you can simply create the cluster and directly manage everything from a single YAML file. I mean, not single YAML file, multiple YAML file. And the point what I mean to say is a set of YAML file. You can write code to manage everything, your infrastructure side and also your Kubernetes side, your applications, everything you can write down inside the YAML file. So this big advantage is a requirement of today. Most of the company nowadays the requirement are very very dynamic. They need a lot of things. They need a lot of disk. They need a lot of broadband size. They need to run thousands of containers, and not such kind of complex requirements are there today. And a managed Kubernetes cluster is a very very good idea to run your application workloads in the cloud. Great.